Let's set up the governing equations in the Fluent solver. Close out of the measure, go back to the project page and double click on setup to bring up Fluent. Select double precision as before and click OK. Here I have Fluent side by side with the summary of the governing equations that we looked at in the pre-analysis step. So let's go and set up these governing equations. First thing to do is to check the mesh. So I'll say check, and that goes through okay. It doesn't complain. And I can also look at mesh scale and check that the domain extents look fine, and that's consistent with what I've given in the geometry. So I'll close out of there. And the governing equations that are turned on are, in the 2D space. So it's a laminar version of these. So these the turbulence stresses are not turned on, and there's no Reynolds averaging that's being turned on. Otherwise, these equations, the equations are similar to the ones here. So nothing to do here. Under models, we don't need to turn on energy because we have enough equations for the number of unknown fields that we have. So we can leave energy off. And under viscous, of course, it's not laminar, so I'll double click on that. And I will select K epsilon. And you see that changes this menu. And what I did with that one click is I switched to Reynolds average quantities, and I turned down the turbulence stresses, and the turbulence stresses are calculated using an eddy viscosity, and the eddy viscosity is calculated from K and epsilon, and it's also turned down the conservation equation for K and epsilon. So a lot has happened under the hood when I click that button. And you will see that there are three flavors of the K epsilon model, and we will pick the realizable, which is recommended by ANSYS because it's generally more accurate and more robust than the other two flavors. So we will go with that. And you can think of it as, for each flavor you have a different conservation equation for K and epsilon. So now Fluent has the governing equations that we need to solve, and the only thing to specify now are mu and rho. So I'll say OK over there. By the way, Spalert-Alhambra's K epsilon and K omega are all eddy viscosity models, and under K omega you will see an SST K omega. That's the other turbulence model apart from realizable K epsilon that's recommended by ANSYS. So I'll say OK. And I'll go under Materials, Fluid, double click on Air. The density is 1.1767, and the coefficient of viscosity is 10 to the power of minus 5. It should be 1.009. So I've adjusted the coefficient of viscosity to get the right Reynolds number. And I say Change Create and close. And then I need to make sure that if I go to cell zone conditions and surface body and say edit, okay, I need to make sure that that's been assigned. And as I mentioned before, in the laminar pipe flow case, it's if you create multiple materials, you have to make sure that that's assigned here. Okay, so at this point, the Fluent solver knows what are the governing equations we want to solve. It knows the material properties that appear in the governing equations. Let's next set up the boundary conditions.